Okay. Sorry, starting a little late here, but got everything under control now, I think. Hopefully we're alive. Let's check that everything's going good levels. Yep. Camera check. Okay, we're good. Okay, hi. Welcome back. It's another week of hacking on Haskell type stuff. I got a game underway that we've been building called LambdaTrek. It's a roguelike type of game, kind of inspired by Star Trek loosely, but more so this really old school game called Star Trek or Super Trek and its many variants and clones, where you are the captain of some kind of spaceship, and there's a bunch of invading ships from some other empire or something invading your local bit of space, and you're on a mission to destroy all those other ships before your time runs out, or you get destroyed. And that's kind of the gist of it. Very simple story, not a whole lot going on there. If this is your first time tuning in, welcome. This is what the game looks like. We're gonna just pop it open. If I could type, that would be great. So we're using the stack build tool here, and that's just for building our project and all that sort of stuff. Pretty useful thing. We use it a lot on the stream. And this is the game. Where we're at right now is we have like most of this stuff implemented, most of combat implemented, not all of it, but a good enough chunk of it. And we're just at the point now where we're implementing the quadrant view. So this is like a little sector of space, a little area. It's like a star, the player's ship, a space station, an enemy ship. And now we want to be able to look at the little area of space that the game takes place in. And we're going to be implementing this little view here where you have different quadrants. And then, yeah, it's going to be kind of like a little screen where you can use your long-range scanners to figure out which sector to try to go to next, that kind of stuff. And so each tile here should have like a little bit of information about what's in there, what you've discovered, what you haven't discovered. So we're going to work out what that should look like today on the stream. As always, I appreciate backseat programming or hot takes and suggestions, so whatever you want, just let it out there. I can answer questions and all kinds of stuff, so follow along and let's dive in. Okay, I'm going to open up the code. It's in the projects folder under LambdaTrek. Bang. We're on the quadrant branch right now, which we should, I think this is like a pretty good branch. I think the design of quadrants, like the data structure, is going pretty okay so far. Kind of like it. We have this record of maps where each index in to the record gets us the current quadrant. It has all the quadrants in there, and then each value in there is just an array of all the data for that sector. And so you go from quadrant to sector using some kind of index. This little function here, get sector, and we have update sector, and all that sort of stuff. All packed in there. Okay, so rendering, I believe, is done here. And building the tiles. So each little quadrant tile here is, we're just using the show instance of the data structure at the moment, but we have to build up the data in this tile and then come up with a rendering function for it. And what I'm thinking is that each tile will be like a little card with a few icons on it. Maybe like one icon will be for like where the player's ship currently is, which quadrant it's in, which we could just reuse the S from the sector view. And that'll be a little bit of consistency there. And then we need some information for what you've scanned. And I guess the 3 bits of information will be enemies, space stations. And maybe like stars, I don't know. Maybe 2 for now. If we decide to simulate other parts of the universe, like planets and stars, and we can go to them and do stuff there, then maybe we'll leave a little room for a couple more. So something like that. I think we'll be good. So I'm going to go to my quadrantile type here. Right now it's just an int. We just kind of blocked out this code. Now we actually have to like implement stuff here. Okay, so what are we going to do? We're going to have the tile's going to have the current. It's got to have a space slot for the current ship. Let's make it a record. Data quadrant. Go to this int. Okay, we'll have quadrant tile. Let's see. Player ship. That has to be present. So we could just use a flag for it. Boolean should be fine. Is player ship present? And then quadrant tile. Now, for discovered or not discovered, also just a binary kind of choice. Or scanned. Has enemy ships. Maybe we'll just be a little consistent here. Let's do has. Has player ship. Has enemy ships. Right? So long-range scanner could tell you there are enemy ships present, but you'd have to go to the sector to find out how many, maybe. We might change our mind about this later. Has Starbase. That should be good enough for now. Alright. So I'm thinking they should be like maybe a 4x4 grid kind of thing. And we'll try and render these somewhere in there and give it like a nice little border. Okay. So that's our quadrant tile. Now, of course, this is not going to compile anymore because here. So let's fix those problems. Yeah. Quadrant tiles. Let's see. Int array. This should be quadrant tile. Let's bring that down to the left a little bit. There we go. Okay. Okay, so get tile here. We get the quadrant data from quadrant tiles, and we're constructing it here. Which we don't really have to do, we just have to return it. We don't have to use the constructor anyway, it should just be there. rendering it similarly. So get the quadrant tiles, map, second, from the association list. Okay, and now we have one more problem where we have the build tiles function. So before with build tiles, I was just filling in dummy data. I was like, whatever, man. But then we actually have to fill in some data here. Okay, so let's go through our quadrant, pull that into scope. And what's the first thing we got to do with the quadrant? Well, we got to go through all of them. So we go through the quadrant map. All right, so go through the quadrant. We go through each index here. Okay. We turn this index into an int index. And we map this data into our file. So if it has enemy ships, like this array is not empty, we'll put a T there, true, and same for stations. Okay, so the map has a map function. Map with key, though, I think is what we want. And quadrants. We're going to want to do all of those, traverse all of those at the same time. We know they're going to be all the same size. So maybe we'll be able to zip them together. Yeah. We need some way to traverse this structure, basically. Let's look at traverse. Yeah. Collect the results. Map each element of a structure to an action. That's this little guy here. Evaluate these actions from left to right over this thing, this traversable thing, and collect the results in F, T of B. Kind of. Might be able to do something like that. We could probably just pull out the quadrant parts. This. We can build out the elements into lists. And then zip all those together into our quadrant tile. So let's go. We just need the ships. And I think just even has enemy ships. We might be able to do this whole transformation in one go. And has space stations. Or star bases, we call them. Okay. Put those there. And then once we figure out what those are, We want to create a quadrant tiles. Yeah, we have to compose. We need to ultimately pass in this array from lists. Oh, it's not array dot from list. What was it again? It was list array. Right, and that needs the index bounds, which we know is going to be from 0 to, what was it, 4 by 4? So that make it 16, so 15. And then we're going to zip together. Zip needs 2 lists and a function, I believe. Oh, we want like a zip and then something else, actually. Yes. So has enemy ships. This would be what we want, and has star bases. Ooh, and we want has a player ship. Okay, so that we actually want something like zip 3. Let's Google that one. Let's Google it. Is there a zip 3? Oh, it should be a base, yeah. Okay. Cool. And as player ship. Bring that over to the left a little bit. Okay, so this hole now is the tuple of all those 3 things to construct our quadrant tile. So we can map Uncurry 3, maybe? Could write it A, B, C like this. That's a tuple. Okay. And then as long as we can fill in these holes here to be the things we need from the quadrant data, then I think we should be good. Okie dokie. So how do we get has enemy ships? We want a list of booleans, essentially. So we're going to map over the quadrant enemy ships. And, ooh, we still haven't really taken care of making sure that these end up in the lists in the right order in the array. I don't... Well... Data.map.strict is ordered. we might want to return the keys with them and provide our own function to make sure that we're mapping the right quadrant data into the right place consistently. Let's see how this goes here. It should be pretty easy to extend to that if we need it. Okay, so I meant this one, I guess. Whole should be array int enemy to b. So we just need to know if the array's size is 0. Let's see, it doesn't look like arrays give us a way to query its... Well, it's going to have a fixed size, that's true. So actually, our function should be mapping over this array and making sure there are no destroyed enemies. This might be somewhat super inefficient, but we'll just convert it to a list and do it that way. Elements. Something with array.elements. Alright, so then we get a list of enemy to be, and we want if any of them are alive, then that should be fine. That should satisfy us here. So I think enemy has a destroyed state. Enemy state hit points. So if the hit points are non-zero, are greater than 0. We could write the enemy hit points greater than 0. Oh, it's capital P. Okay, not the prettiest function. We'll clean it up in a minute. At least the type checks. That is about right. Has star bases. This is like has star bases at all. So we could take something after we get the array.elements again here of the quadrant. I think I might have called them stations in there. I don't know. Hopefully I didn't. Quadrant stations. I get my naming straight here. Why is this a problem? What's going on here? Quadrant stations, array of int station. Oh, we're missing an apply here. That's right. Hello, I'm awake. What's going on? Okay, and array.elements. Here, let's bring this over a little bit. Ah, that's why that works. Don't really need this here. And that's a map.map. So the m.map. Okay, and then this becomes a list of stations to be, and all we care about are no. All we care is that there are any. This quadrant stations is the length is greater than 0. So we need map dot values, something like that. Elements. Mirror. What do I need here? You are a map. I just need to get the values out of you, which will be all the arrays. No, I'm not thinking about this right. This is not right. This is not right. What's the type of has enemy ships gonna be, you think? It's gonna be a map! I don't need that. What am I doing? Whoa, my gosh. What about we fold? Fold the map down into our list. Start this over again. Okay, and we're going to accumulate into this list something, and then we want to see if any of them have that hit points. Have damn hit points. Fold our it's a function of two elements, A and B, returning possibly a B. A is our values, B is our accumulator. And then that should be our map. So this should be enemy lists, enemy array, enemies, and accumulator, something like that. apply in here in order to clean that up a bit. Okay, cool. So now we just got to return a list of enemies. This is just here's what we can do. Our iri dot elements enemies, and we can accumulate those on the accumulator. I think that'll work, maybe, hopefully. You never know. You do know. Okay, let's see here. Back to this. Let's check what type is big enemy ships is. Oh, right. Any returns a bool. We want a list of bools. So we want to move this. Yeah. I'll move this in here. To a map in here. Yeah. There we go. It's ugly as heck, but we will fix that. Okay. I think that's what we want. So this will be the flattened list. I'm still not sure this is what we want, actually. No. I don't think this is. So we don't want to flatten the list. We want the chunks of each for each quadrant. So when we zip over this and we construct a quadrant tile, that quadrant tile's A has that list of enemies and whether there are any alive or not. So that when you do the scan, all right, and we have the function over quadrant tile called scan, and the scan would look for like scan for enemies, and then we'd have a function. Are there any enemy ships that are still alive in this quadrant tile? Yes or no? Which would flip the flag around for us, and we can re-render all that sort of stuff. So yeah, we don't want to fold down the whole map. Hey Alice, what's going on? Nice to see you. Welcome to the stream. Hope you're doing well. Yeah, so we don't want to extend the accumulator. We want to cons onto the accumulator our folded down list, I think. So we get a list of lists. Okay, that's going to throw a type error down here probably. Yeah, list of lists. Right. Yeah, that's because quadrant tile is just going to, it just has bool. Yeah, so we could still squish that down even further. When we're constructing the quadrant tile, we can just put that question here. And then we have the query alive enemy ship. And this is just if the health is not greater, it's still greater than 0. Enemy hit points greater than 0. Okay, mesh, I think that'll fold down better. Okay. What's the problem here? Oh, no, now I think the problem is that these have to be all the same shape. Yeah, so star bases. Similarly, fold our something down to there, and we'll get quadrant stations. And this function will be something. Stations is our array of in station, and we're just going to pop those stations in there and cons it onto the accumulator. So after we do our array.elms on stations and cons that onto our accumulator, and then star bases. Query here for B is the length of B is greater than 0. Right, and then this one is one of these wants to be a list of enemies. We have a list of bool. What's a here? What am I doing? I'm getting things mixed up a little bit. Let's see here. Here's a list of bool. Oh, because I already compressed this down. Alright, this maps the list to the bools. List of bools. Oh, we already did that, so we don't need this. Oh, we just need the... If any of them are true, the whole list is going to be true. That is the function. That's the conjunction of all of the elements. Oh, come on, what is it, brain? And yeah, they have to be all true. No, we want the disjunction, right? Any of them are true. Then it has enemies. Oh, it needs argument A. There we go. Okay, cool. Super duper. Okay, and let's fix that, and then we just have to figure out player's ship. And that comes to the quadrant. No, that comes from the game state. Hmm. That comes from the game state. We're gonna have to pass that in, I think. Yeah, something like that. I'm just gonna put nothing there for now. And ignore C. And just make it true. Okay, not null B, sure. Some name shadowing. Redundant apply. Okay, I misinterpreted what it was saying here. This apply is redundant. Okay. Oh, and this is just to move brackets to avoid an apply. Okay, whatever. Whatever. Okay, now what? Wants me to do almost the same thing. Just remove the brackets from outside the map. Okay. There we go. Okay. So let's get the builder going. Build. We'll just run it with the test. Build it with the test runner. Fast. Watch. Now let's see if we get the right data in the right places. Oh, I'm not in the right directory, am I? No, I'm not. Look at that. Just do that. Hey, Gruner Coder. What's up, Gruner Coder? Enjoying the game dev, enjoying the Haskell? Bit of both. Okay, so compile. So obviously it's going to work. No. Okay, cool. Undefined array element. So that's obviously not true, especially when you're using these things. Let's see. Undefined array element. when we're indexing into, where do we use that? Get tile. Yeah. Are we calling get tile? No, it's just how it's sitting there all by itself. Where else am I calling that? Okay, the other thing it might be in list array trying to construct this and this map isn't actually big enough. Or these lists of lists aren't the same size exactly. That's probably what's going on. Yeah. Yeah, I think that's exactly what's happening. So let's just see that. I don't want to show you. Not post positive. Okay, so we have build tiles here. I'm going to erase here. And we'll just show has enemy ships. And has star bases. RBCs, yes. Okay, good. GRU encoder, I could not agree more. It is a very underrated programming language. Sometimes notorious, mostly pretty chill. You know? A lot of folks using it just kind of get their work done and, you know. Me, I gotta show off a little bit. But yeah, that's what we're here for. Okay, so we got our like happy little print debuggy. So if I try to open up my map, it's not gonna print it. So it's just gonna go straight to that IO error. Yuck. Okay, so how can we do this? Let's just empty the, let's just comment this out and this out. Let's put in our little infinite map of just true. Render is gonna be fine if I make this just the empty list, hopefully. Oh, I forgot that. I got that. I can leave it. Yeah, let's not worry about that warning right now. Let's just get it to build. Good. Let's run it. Let's pop over to our map. We still get the undefined array element, but it's not printing out my debug. Four goes. Okay. Okay, let's just do this from the GHCI then. Okay, so we go build tiles from init quadrant. Where did I learn Haskell? Oof. Well, the first time I tried to learn Haskell was like way back. If you look at on my blog, I think I bounced off at around 2008 or 2009. And I was learning from a book called Learn You a Haskell at the time, just purely out of curiosity. I think around that time there was quite a little bit there's quite a bit of like functional programming evangelism and like Haskell rah going on at the time on the internets. And so I was curious and I tried it out. But it didn't stick for me, mainly because like I wasn't using it in my day job. It was hard and I had other things I wanted to do than fuss around trying to learn this hard language that I wasn't really going to use. So yeah, didn't work out. But about 5 years or so ago, I picked it up again when I was like trying to do more functional programming, but I wanted to like try functional programming in a more strict like functional programming language where it's like the primary design of the language. And at first I tried OCaml and I did the INRIA course online for that. And then I tried at the behest of a colleague of mine who would not let it go. And a colleague of mine like I totally respected immensely for teaching me a lot about formal methods and such. So I didn't want to sound like kind of a moron around this person who spent all this time teaching me maths and formal methods. And I had really poor opinions about Haskell from the first time I bounced off of it. So when I went to go relearn it, I bounced off of OCaml and I took a course from the University of Glasgow. I read a bunch of books. I can't remember which. I think Real World Haskell and the concurrency one Simon Marlowe did. And this time I wasn't going to let myself just kind of like not use it at all, because that's what made it slip. And so I stuck with it this time by sneaking it into small side projects at a job I had a while ago. Little out of the way projects where it didn't really matter the whole that much. It had really no consequence. It was just doing kind of like migration type jobs that would just run off and just do a bunch of things, which was pretty fun and a pretty cool project. Taught me a lot, and it stuck with me ever since. And now I program in Haskell full time as my job, and here on the stream for funsies. So only university. Is it illegal to learn it any other way in your country? Yeah, I hope I didn't speak too fast, by the way. But yeah, basically, I didn't want to seem like a moron. And a friend of mine was really into Haskell and insisted I learn it, so I did. And I formed better opinions by it. And changed my mind about Haskell in the end. Like, I had the usual, like, opinions about Haskell. Oh, good. Oh, that's alright then. Sometimes when I get excited, I start speeding up. Okay, so I want my debug trace here to print out my stuff. I call build tiles. It's not. Is that because debug.trace has to be run in a particular context in order for that to work? I don't know. Apparently not. Okay, I'm gonna just get rid of the debug trace and see if my theory is right about this being the construction of this array being the problem, the mapping over to zip3. Yeah, oh, because zip3, that's gonna be the issue, yeah. Zip3 is gonna be like, it's gonna cut, everything has to be exactly the same length or it's gonna cut stuff off. That's why. Ah, well, you're in the right place. This is exactly why I started the stream. I was I found the content online fairly limited. There weren't a lot of people writing Haskell just to like do practical things like make video games and stuff like that. The Americans are much better programmers. Maybe, but I'm Canadian, so I wouldn't know. Right, so this is no longer the empty list. That's fine. Let's bind it something. Okay, so it's not constructing the tiles that's the problem. Oh, we don't have a show for that. It's rendering it then. You know, maybe. I don't know. I do know that one time I was in France and everyone there, when my partner and I were visiting, assumed that we were American right away and weren't very hospitable, I would say. You know, like polite enough, but not like nice, let's say. We got turned away from places and when we wanted to go out for drinks or whatever because they thought we were American. So one time I had enough of it and I answered the waitress at this cafe in French. And she was like, the first thing she said to me was in French, well, you know it's different here, right? It's like, yeah, I'm aware. Super fun Canadian stories. Okay, so this zip approach is not going to be super great for building the tiles out of the quadrant because these arrays are going to be staggered in size. And so zip is only going to be as long as the shortest list. So this is not going to be, this is going to be no bueno, this approach to building tiles. Okay. I'm kind of not liking the quadrant structure that we have set up here. Ugh. Oh, that's why they don't like Americans, is it? Maybe if anybody in chat is from France and wants to fill us in on the deets, let me know. I'm curious why we were treated so poorly and everyone assumed we were American. they didn't treat us poorly, but like, you know, getting turned away from being like, no, we don't have any seats here when there clearly was space, or things like that. Okay, so build tiles isn't gonna work this way. Maybe we should build up the quadrant tile from what we have in scope here without zip 3. God, it's almost like I want to implement some way to map over all of the quadrant data in parallel and get the sector data. That could be one way we could do it. Maybe we could iterate through the coordinates and just get the sector, each sector out of the quadrant. And then we have a function that maps from sector to quadrant tile. That might be an easier path. And then we could chuck that into this array. Or maybe we get rid of this array altogether and just make it a bloody list. Let's try that. Let's get rid of this. Make it a list. We don't need this chunk here. Okay. Get the tile out of this from int. This just needs the list accessor. I think data.list has a similar one. That's unsafe, but famous last words, should be safe here. Which is bang bang in this case. Bang bang. Index list. Let's go. Okay, now we don't need this. This will compile, but it'll still be wrong. Okay, all right. So we're not going to be able to build the full map yet because I don't think we have the industrial quadrant set up for all of our data, but we should be okay. So let's compile this right over here. Okay, quadrant tiles. And I think it'll crash maybe still if I switch over to the map. No, it won't. Sweet. Okay. That's a blessing. So now we just need to render the tile and then add more tile and add more quadrants and clean this code up from being so ugly. But it should be good. Although I still think we have the problem with the zip bit. I think that's still an issue. Right, if we go zip 3, and we have like a list here 1, 2, 3, a list of 1, 2, and a list of just 1, we're gonna get we get 1, 1, 1. That's it, right? A single tuple. It's gonna take it's only gonna zip up to the shortest list. All right, it's not gonna create a tuple of just 2 elements, which would be like 2, 2, and 3, something, something, right? So that's why we can't use zip. What does a Canadian earn as a programmer? It varies quite a bit, but it is definitely quite a bit lower than our American counterparts. Anecdotally, I know that a good number of Canadians a lot of Canadian companies will pay like a top end senior developer 90,000 Canadian to like 100,000 Canadian, maybe 110. Some bigger Canadian companies or Canadian companies that have American subsidiaries, like Microsoft has offices here. They'll tend to skew a little bit more towards American level salaries, but will still be cost adjusted for local economy stuff so that they can get well-educated people for cheap. That's essentially what happens, unfortunately. And so Canadians typically earn a bit less than Americans, but we also like don't have to pay so much in terms of healthcare costs and stuff. We have other benefits, you know? Not all bad. Okay. So build tiles then. We can't use zip 3. That's not the right thing. I'm thinking we should iterate through our coordinates, pulling out the sectors, mapping the sectors to the thing. So iterating. We need a way to iterate through completed applications of F to X. That would give us, well, we know what the structure is anyway. Like we could do that with a list comprehension, right? From 0 to, I think it's inclusive. Let's just check. Y, U, from 0 to 14. 15, sorry, because it's 16 in total. And 0, 0, 0, 1 up to 15, and then we start on the ones. So that gets us all of our coordinates. We can even make that quadrant coordinates. I'm gonna do something with that. I'll define that up here. That's gonna be a list of our coordinates. That over there. But okay. We want to do with that. So we have now a function from a list of coordinates to quadrantile. We have a function to go from a coordinate, if we uncurry, into the quadrant to get a sector. No, straight. We don't even have to uncurry. Just a straight coordinate. So I have to pull in the quadrant. And we're going to map into that. Okay. Now we have to go from a list of sectors to quadrantiles. Well, we could get a function from sector to quadrantile that would get us to a list of quadrantiles, and then we just have to pass that to the constructor. Simple dimple. Okay, let's go. Let's write that here. Sector quadrantile. And move it down below this definition. Let's even just call it 2 quadrantile. I don't think I've named anything that yet. And pull in the sector data, that sweet sector data. Okay. We know we need to construct a quadrantile. That has 3 fields. I'll just pop this in there, like this, make these equal to something. I'll do that again. Maybe if I could type, that would be great. Okay, and then we just got to put booleans in these holes. So in scope for has player ship, we just have star stations or whatever, so we still have to figure that out. I'll just put false there for now. It's a little to do. Okay, enemy ships. We now have the sector enemy ships. Alright, it's going to be array.elements. Something. List of enemies bool. And then we know any alive. And we pull out that enemy, and if the enemy hit points that we've been typing over and over tonight is greater than 0, we're good. One more hole to fill as a star base. Okay, so this, we're going to take the array elements of the sector stations. And we're just going to test... no. Okay. Our last hole we have to fill still is in build tiles now. We have a list of sector to quadrant tiles we know how to get. Transform that list. To quadrant tile. So now we have a list of quadrant tiles to quadrant tiles. That's just with a D. Okay. Now compiles. And the grade test. Whoa. Given key is not an element in the map. Uh-oh. So we used an unsafe index for map. That is... Where do we use that? Get tile? No, it would be... Get sector? Yeah. So we can't use... an unsafe map there. Right, so the reason why that's failing is because like our initial quadrant doesn't actually have all that data. We would have to populate all of those quadrants now in order to do that. All right. Let's see here. How do we want to do this? Okay, we have all of the sector coordinates in the quadrant, in quadrant chords. We can make every coordinate, every quadrant have an enemy, a star at 1010. It's fine for now. Sector enemy ship map. We can do the same thing here. And we just change this to chord. And similar transformation here. Quadrant chords. Okay, now we have no invalid indices in there. It should be safe again. And booyah. Okay, if we want only some of them to have enemy ships, just add a little conditional here. If the coordinate is equal to 0, 0, then list array, else empty. Alright, that should be fine. No, that's gonna blow up in my face. Ah! An array with no elements. That's not gonna work. I think it's because that array.elements. That's interesting. So, can we put a -1 there? Or does array apply at least one element? Okay, -1 seems to be fine. Yeah, so then enemy ships, we've got mostly false, just the one true. Sweet. Okay, that's what I wanted. Good to know. Things to learn. Okay, it's 4 by 4 is 16, right? Yeah. That should be enough. Okay, so let's actually render these things. Let's see, what are we doing on time? 9:39. Okay. Going a little slow tonight. That's okay. That's okay. We got all the data we need to render it now. So instead of using well, let's commit this. And then get to rendering. We'll update build tile. Okay, and rendering. Okay, I'm thinking they should be like, we said we got like 3 pieces of information: the player ship in there, the enemy ships, the starbase. We want to leave a little bit of buffer in case we want to add more stuff that you can scan for and you want to show up in there. So I'm thinking maybe do 5 blank tiles wide. So we have 3 in there. That'll leave one more tile on each side. We could do a row above, empty row above, and empty row below. And then try and surround it in some borders. That would be pretty nice. Let's pull in the quadrant tile data. It'll be like 1, 2, 3, 4, 5, and then a little plus. And let's go like this. And then 1, 2, 3, 4, 5, and then here. We'll put something there. So for now, we'll just, if you don't know anything, we'll just put like question marks there. We haven't scanned it yet. Another empty row. And then our kind of end cap here. And in order to render this the way we want, we're going to have to put the new lines on here, I believe. This might not render the way I think it's going to. Not quite. We need to render these in a grid. Yeah, that's not good. If we do it like this, that's not going to render it either because it's going to go along the row. So when we call render row, we are just intercalating these borders with the text that we get from calling render tile. This is not going to work. We need a way to scan together the row because it's going to be multiple lines of text. You know what I mean? We need a grid rendering function of some kind. Oh boy. I have no idea how we're going to do that. Well, we know the width of these is going to be 5 plus 2 is going to be like 7. Right, so each of those is going to be 7 glyphs, or 7 characters wide for each row of our tile we want to render. So we need to render the whole, for each tile, the first text row, then the second text row, then the third text row. For each tile, I think. It might be the way we could do that. You know? I think that could work. And that's how we render the rows. And then, yeah, we can, and then t-intercalate with the new line after we do each one. Should give us our grid back. Yeah. And we know how tall the tiles are. like 1, 2, 3, 4, 5 rows long. Okay. So I think what we kind of can do here, instead of render tile, render row. You make render row smarter. We have render, we can break this down maybe to like a function, call it render tile prime. That will take the row number of this glyph representation type thing to render. And the list of quadrant tiles. And produces text. So on the 0th, it produces this repeated with spaces. And infinitely 7 times. Seven times exactly. Which is not this. It's going to be bang or owl. The problem is jumping around here is it's all symbols. Take 7 from the repeat of this. We don't need quadrant tiles in this case. Replicate 7 is the function I meant. Okay. Let's do it on row 1. It's going to be almost exactly the same. Except the chunk is going to be that. And on row 2, it will be this. That. Yes, I know it's not exhaustive. That's going to be fine in just a second, GHC. Okay. Row 3. Going to be much like the first. And then row 4 is going to be like the last. The first, the 0th. We have a completed picture. We're good. Anything else, it doesn't really matter what it is. We don't care. We're not actually going to do anything with it past 4. Hey, Exuberantha 2. I don't want a promotion. Thank you. You can go. Bye-bye. Okie doke. I'm sorry for the interruption. We're back. Okay, so we have render tile. Render tile now renders this one row at a time. So then we should be able to change this. And we're going to map over, let's see. So render of row is going to get a list of quadrant tiles. And we want to transform that list into a list mapped with the indices that we want to pass to render tile for the different text rows. Yeah, so from 0 to 4. Right. So we will take tiles. Let's see, quadrant tile to text. This is what we want. How are we going to do this? Tiles. Let's see, okay. List of quadrant tiles in scope. We're going to let's build up a tuple of row index, text row index, and tiles. In 0 to 4. We're gonna do something with that. Okay, so now we've got the whole list of integer quadrant tiles of text. Okay, let's turn that into a map. render tile prime. Okay, GHC just can't figure out what the type should be yet. That's okay. So we're gonna get a text here. Intercalate. We want new lines between each of those rows. Can't put that there. Okay, so now this whole, we've got a list of the rendered text rows that we want. This is where we got to put the intercalate. Okay. I think we'll be okay. Skadoosh. Okay, so this is a bit too big, but this is the tile map. This is good. I think maybe if we make it a little bit, how big is it? Okay, well, my estimations of the of the size of it is too much. Well, we can tweak that. So it's going to render it no matter what, which is nice. We've got how many rows? 1, 2, 3, 4, 5, 6, 7. Oh boy. Oh, That's this. Why did I need to replicate 7? No. We need to replicate however many quadrant tiles there are. Right? Yeah. Yeah. Replace these all with T's. And these all with length of T's. That's a little odd. Okay. Now it should be there. 4. 1, 2, 3, 4. Okay. Now we got 1, 2, 3, 4, 5, 6, 7. How many rows do we have? More rows than we need. I only wanted 4 rows. So the size of our galaxy is a little bit big. That's okay. So let's get to the middle of the tiles. We're running a little low on time. So in this case, on row 2, that's where we want to actually interpret what's in T's here. So we don't want to replicate this as a string. We want to map over it. Quadrant tile to text. and render quadrant data. I'll put that down here. That'll be quadrant tile. To text. Okay. Let's pull that into scope. Booyah. Okay, so render has ships. Render has, we'll make the first one ships, the second one has stations, and the third one has layer ship. And then we have the last space on the end. And then this one can just be if Quadratile has enemy ships, then what should the representation be? Like the ship symbol. This is what we use in the sector, so why not here? It has stations. If the quadrant tile has stations, starbase, I called it by accident because I'm smart. And then the starbase symbol, station symbol, tiles merit, has player ship. We still have to fix that. But if we have quadrant tile has player ship, then we can do S. Well, it wouldn't be, it would just be blank. Or maybe an underscore. Super duper. Sick. Okay, so this one has enemy ships. Has a station. No player. We're gonna have that. We just have to get this line up properly and put these back in. That'll be right there and right there. Simple enough. Bang bang. Let's get some. Come on. Bang. Boom. Great. There's our tiles. Okay, so on this screen now, we've got our quadrant tiles rendering in a grid with these little squares that show off the tile. So the idea here is this will be like when you want to warp to a different sector, you pull up this screen. Most of these will be unscanned, so they'll be just question marks. One of these will be an S, and that's the quadrant you know you're in. And the idea is that you'll use your long-range scanner command on this screen to scan out amongst the stars. And then you can jump and warp to the different sectors from there. So we're getting there, friends. We're getting there. Let's get rid of this bad boy. Let's replace render tile prime with just render tile. Make sure that still builds. That should be fine. Okay. Boom. Okay, what else? What else? That looks okay. That looks okay. This is fine. Let's just pull it over the left a little bit. This could be nicer. What did I do? Oh. I see what I did here. No, I could stay. It's fine. Not the worst thing. Don't need to get clever. Let's get rid of that. Let's clean up any warnings we have in our build. That data.list, bang bang. We don't need that anymore. Bye bye. Any others? That's it. I think we got a clean build after that. Cool. Let's commit that. Update render. The quadrant map rendering. Let's reword that. Just add a little alpha message. Quadrant tile rendering. That should be the name of it. Add quadrant tile rendering. Okie dokie. Alright, so that's good. I like that. That's nice. We still have to fix the player ship thing and the too many rows problem. And then we have to make sure that these are getting rendered in the right order. So instead of 0 to 15, let's go 0 to... If I just shorten the number of coordinates, it will still render and work. Okay, okay. Didn't break, didn't crash. So indices accesses are still going good. Now we're still getting a lot of more rows than I want. That's better. Still getting 1, 2, 3, 4, 5, 6 rows. 24, 25. So this is producing 01, 02, 03, 04. 1, 2, 3, 4. 3, 3. There we go. Let's get it. Let's get it. Am I right? I can't do math tonight in my head for some reason. There we go. That's the map we want. 4 by 4. That should fit in a good number of terminals. So you'll need a decent number of lines to render it. Maybe we should make this area scrollable. That's possible with brick. But we'll have to. That'll be a touch-up thing we can do later on. But there we go. Okay, so we still have to like render the player ship status where we are, and then cover up the rest of these so that they're unknown. And we'll have to add scanning, the scanning effect and mechanic and stuff. Because I think this is actually kind of somewhat wrong. We want to know if it's been scanned or not, and then if there's this in it. So we have to add that mechanic into the game, I guess, at some point. But they'll have to wait till next week. Thanks for joining me on this stream. It's been a journey. And yeah, I don't think we have any code update. What did I modify? Just that. Okay. Boop. Get that in there. Thanks, DV2. Oh, Devo. For tuning in and watching. It's been great. So all the code, if this is your first time tuning in, or if you're cool and you've been watching this whole time, either way, the code for this project lives up here in LambdaTrek on the GitHubs. I'm Agent Ultra. It's been wonderful. And we'll get this merged into mainline next week, I guess, because I think it's turning out pretty well. And yeah, then we'll add some more commands. We'll add some scanning and warp drive type stuff and figure all that out. I do these streams once a week on Tuesday evenings at 10 after 8 in the Eastern Standard Time Zone. And you can, click the notifications and the followings here on the Twitch to get notifications when I go live, or if you're watching on YouTube, because you're on my YouTube followers, to do there, hopefully, and to get notifications when I upload a new video or a new stream. And what else? Go to the link above. There's a Discord server there if you like hanging out on Discord servers. What's one more? This Discord server is pretty cool. There's a channel for this stream here. We can talk about your projects, ask questions you don't want to ask on stream, whatever the case may be. It's there. And follow me on the socials as well. Of course, I am on the Types.pl server, and I'm Agent Ultra there as well. Yeah. So that's a moi, your wonderful host. And you can talk to me about Haskell, whatever you want there as well. And I also post updates and stuff to things there. So, yeah. Get it? Hope you enjoyed. I'll hopefully see you next week. Take care out there. May your monads always be free and your types always check. Happy hacking.